Hi everybody. Today this is Mrs. Gifford and we are going to talk about section 4.12, scientific notation. And with this lesson, students will be able to write numbers in both standard and scientific notation. So first of all, what is standard form? Standard form is a style that we just normally write our numbers. For example, if I want to write the number 12,000, this is considered standard form. It's just the basic way that we see that we write numbers. Now, what is scientific notation? Scientific notation is a method to help you express large or very small numbers. It is written as the product. Product means to what? Multiply of a number that's greater than or equal to 1 but less than 10 and a power of 10. So if we look at this example, we have 5.878. This number right here is greater than or equal to 1, but it's also less than 10 times, so that's showing our product. We have 10. We just talked about powers of 10 with the last lesson to some exponent. So in this case, our exponent is 12. Now let's take a look at some other examples. Earlier we talked about repeater machines, and so here's an example of 3 times 10 to the second power, which in standard form, that's 300. We have 6.5 times 10 to the 7th. This is 65 million. And we have 2.528 times 10 to the 13th. And if we look closely, we will end up having 10 zeros, 3, 6, 9, 10. Okay? Because very shortly we're going to talk about how to convert from scientific notation into standard. So the first thing that we need to do is, based on that definition of scientific notation, we have to decide if numbers are written correctly in scientific notation. So I have 2 examples. The first one is we have 0.9 times 10 to the 4th. So we ask ourselves, what do we notice about this number? Well, based on the definition of scientific notation, I know that this first number has to be greater than or equal to 1. And you have to ask yourself, is 0.9 greater than or equal to 1? No, it's not. So we say, no, this is not correct. And we say it's not correct because 0.9 is not greater than or equal to 1. So let's take a look at the second example. We have 3.94862 times 10 to the 7th. And we do the same thing. The first thing we ask ourselves, is this first number greater than or equal to 1? Well, yes, 3.9 is greater than or equal to 1. Is it less than 10? Yes, it is. So far, it's correct. Do we have a product? Yes. Do we have 10 to some power? Yes. So in this case, example 2 is written in the correct form. Again, scientific notation, first number is greater than or equal to 1, but less than 10 times 10 to some power. Now, let's take a look at writing numbers in standard form. So we're going to go from scientific notation into standard form. So I have the number 7 times 10 to the 4th power. The first thing that I like to do is I like to rewrite my first number, and I ask myself, what's my exponent? In this case, the exponent is 4. So then I say, well, I know in a whole number it's hidden, but there's a decimal point right after it. And since my exponent is positive 4, I'm going to move my decimal over 4 places to the right. And what do you think goes in those empty loops? Zeros. So in this case, I'm going to put 4 zeros. So we say that 7 times 10 to the 4th is the same as 70,000. Okay, let's do another example. In example 2b, we have 3.216 times 10 to the 9th. Again, I'm going to rewrite that first number, and I ask myself, what's my exponent? Here my exponent is 9. So I'm going to take my decimal that's in that first number, and I'm going to move it 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my decimal. And just like the one up above, what do we fill those loops in with? Correct. We're going to put zeros. Now notice in this case, this one only has 6 zeros instead of 4. So the big thing to remember here, the exponent is not the number of zeros. Is not the number of zeros. It's the number of places to move the decimal. That's key when going from scientific notation to standard. So if we were to rewrite this number, again, we put our commas in from the right. So we have 3,216,000,000. So let's take a look at another example. We're going to write each number in scientific notation. So example 3a, we have 134 million. So the first thing that we need to do is write this out in standard form. Well, this is 134,000. I'm going to add 3 more zeros to make that 134 million. So just like before, going from standard notation into scientific, from scientific into standard, we have to move the decimal to go from standard to scientific. And where is that? Well, it's hidden, but it's right here. So now we need to move this decimal until we get that number that's bigger than 1, less than 10. So typically speaking, you're going to go all the way until you have just one number right that's left over just to the left of that decimal. So now I'm going to count how many places. 1, 2, 3, 4, 5, 6, 7, 8 is how many places I need to move that decimal. So if we write this in scientific notation, I say 1.34, we write the non-zero digits, times, we always need 10, and then you ask yourself, how many places did we move that decimal? We moved it 8 places. So I'm going to put a positive 8. Okay, last example, same thing, the decimal's hiding right after the 0. We have 42,130,000. I'm going to move that decimal over until I get to a number that's basically between 1 and 10. In this case, we're going to stop between the 4 and the 2. So I've got 4.213 times 10, and again our exponent is the number of places we move the decimal, so in this case it's 10 to the 7th power. Alright, last examples. We need to write each of these 2 examples in scientific notation as well. These look like scientific notation, but if you look carefully, this first number does not fall into that greater than or equal to 1 but less than 10. But we can change it. So we've got the number 24. And just like before, I'm going to move that decimal over 1 place to the left, times, and now we have to do something with this exponent of 3. What do you think that's going to be? We're going to add one more onto that, so 3 plus 1 becomes 4. So when you move that decimal, this exponent here that you have in the scientific notation is going to get bigger. Move the decimal to the left. Exponent increases. And as you might imagine, in a few days we'll talk about what happens if we move that decimal to the right. Instead of increasing that exponent, then it'll decrease. So let's do this one last example. So we've got 0.8391. Again, this first number is not greater than or equal to 1, but less than 10. So what do we want to do? Well, all we have to do is move this decimal over one place to the right-hand side, because now we've made that number 8.391. Now up above, we moved that decimal to the left, so it increases that many. And in this case, we move this decimal to the right, so what's going to happen? It's going to go down 1. So we have times 10 to the 4th power. So again, just like up above, if we move the decimal left, the exponent increases. In this case, if we move the decimal to the right, the exponent decreases. All right, folks, there you have it. Some real basics on scientific notation. Best of luck.